When working on an infrastructure project, it's very important to know where you're standing and your location all the time. Since these projects are normally extended along the city or covering big distances, having the possibility to know where you are and have a special awareness is crucial. In our app, you get that by looking at the blue dot that is marking when you open the app. That is always marking your real-time position. The thing is, since we're only using the GPS that's coming from your phone, the accuracy of this specific position, it might be within a couple of meters. For some work, you will need more accuracy measurements or more accuracy in the position that you're marking for every task, checklist, or specific measurement that you might do on site. For that, we have integration with an antenna from Emlid, the Reach RX2. Which is a simple antenna that allows you get your precision down up to a couple of centimeters. Let me show you how this works. I have my antenna here. It's already standing on the stick. The stick that comes with the antenna, or that you can use whatever stick that you have as a surveyor, but in this case I'm using the one from Emlid. The total height of this pole is 180, so 1 meter and 80 centimeters. So it's already been set up here for me. But this height is comfortable for me. But if you are working with a different height, or you need to move according to your measurements, make sure that you always take in the high elevation from the bottom of the stick up to, from the bottom of the stick up to the base of the antenna itself. Whatever happens between the base of the antenna when the receiver is being placed in the hardware itself, we take care of that. So it's a simple configuration. Just make sure that you are getting the right height all the time. So I'm going to get back this to my 180, so it's comfortable for me. Perfect. I'm just going to show you how connect with antenna and some what can you do with antenna within Dalux InfraField. So going back here, I'm just going in the location. To get the antenna connected, I'm just going to go for to more. Here you can see a GPS antenna menu. I'm going to click on that, making sure the antenna is turned on. To turn it on, you just click on the button for a couple of seconds. Start going to have a green light, and the antenna itself is going to start blinking white. Once antenna is turned on, you can find it here in the menu. Just give me a second. It's going to start scanning for the antenna. You will see the RX2. When it's connected, you will see it here in the menu. Yes, one sec. Here you go. It's connected, and aside from the antenna, you will also need access to an Entrep network. This Entrep network is how the antenna communicates with a array of satellites that allows the antenna get all the corrections. So actually the accuracy that you get here or in the place that you're standing can get up to centimeters. This setup needs to be done on web for the first time when you activate the feature itself or the connection with antenna. Afterwards it's going to be available for everybody on site. As you can see here, mine is already connected, so I can get back to locations. Here, going back to location, you can see a blue banner on the top marking that the antenna is already connected and is ready to use in the project. So I'm just going to click again on the blue dot marking my position, and you can see here the menu looks a little bit different now. I do have the button to create a new registration, but I also here have on my left X, Y, Z, so I do have my coordinates, and if I'm moving along the project, these coordinates are going to also adjust, so I have always my position in real time. What you can see here on the left is what's called BACC and HCC, so it's the vertical and horizontal accuracy for this project. Right now I'm having 2 centimeters, so it's quite okay for it's pretty accurate for the work that I need, and the connection with my Entrep network is also perfect. A few of the configurations that you might need is the pole elevation. As I mentioned before, you can change that here in case that you made some modifications in the height. I want to keep the 180 that I have from the beginning. So perfect. And the main point is with base I'm using as a correction base. I'm always using the one that is close to me and is already with 2-3 centimeters accuracy, so I don't need to do anything with that. The setup is that simple. It's going to be straightforward. So as long once you connect or once you turn on the antenna and do the connection with your phone, the Dalux app is going to take care of the rest. Some practical use cases for this accuracy, it might be that you need to measure some manholes when you're doing some work for pipings, where the accuracy for the as-built documentation requires that it need to be within centimeters. Or if you are doing some piping or welding, this welding point might be important, and the precision or the position of it, it might also require some centimeter accuracy. This is where this antenna and the accuracy that we're getting in your registrations come in handy. Another use case, and this is the one that I want to address today, is if you need to do some drone flights for your projects, because you will need to do some orthophotos or some do volume calculations in your site. The pre-work for the drone flight is to create some ground control points. These ground control points are normally just marks on the ground. I do have mine here, so it's easy to identify. So when you're driving with the drone, you can use those as a fixed point to do all the stitching of the picture itself and make sure that the orthophoto has the accuracy that is required. So just to show you here, I'm just going to be standing on the mark itself. Depending on how you use the antenna, and you will need to make sure that you are balancing, so the bubble here is centered, so you make sure that you're in the right position. But this antenna is also having some tilt compensation incorporated in the system, meaning that it doesn't matter if you are tilting this from left to right or front, back and forward, the position is going to maintain, because the antenna itself is going to be able to read the angle and the deviation that you have here and do the compensation, so you're always making sure that you are measuring the right points in the right height. So with that being said, I'm just going to create and measure this point. I'm just going to create a regular test. Here I'm just going to do it as a general message, where I'm going to put the subject as a ground control point, GCP. I'm going to put here number 6. Perfect. I'm going to save that. And it's for the test layer, so I'm just going to add here. I might take a picture just to make sure the location is right. Perfect, and that's it. So now you can see here my registration is done, and this is marking the position of the point that I'm just measuring. I already did some measurements for the other control points that we're going to need, so we are ready to do a drone flight in a couple of minutes. Talking about use cases, another thing that might come in handy is when you need to do some volume control. Either you're doing an excavation or you have a pile of material like the one that I have behind me. You can use this antenna to collecting all the points, so you can create a volume. Or since we're doing also a drone flight, you can take that information from the orthophoto and do some post-processing by using surfaces or meshes to get this volume calculation in place. I will show you how to do that later on when we're sitting on the web.